Propositional logic. Some examples are attributed to Kenneth H. Rosen. Discrete Mathematics and Its Applications, 7th edition. McGraw Hill, 2012. Tools for propositional logic. In this section, we will use the following tools: truth values, truth tables, Boolean logic, meet, join, and negation. Implications: the implication if, then, and the implication if, and only if. The contents of this lecture are 1. The negation of propositions. 2nd conjunction. 3rd disjunction. 4. Exclusive or. 5. Conditional statement if P, then Q. 6. Biconditional statements P if and only if Q. 7. Truth tables of compound propositions. 8. Logic and bit operations. What we mean by propositions. A proposition is a declarative sentence that is either true or false, but not both. Examples of propositions: South Valley University is in Kena. South Valley University is in Asyut. 1 + 1 = 2. Examples of not propositions. Do you like this class? There are X students in this class. X + Y = Z. The negation of propositions. Let P be a proposition. The negation of P, denoted by not P, is the statement, "It is not the case that P." The proposition not P is read not P is the opposite of the truth value of P. The truth value of the negation of P is given as follows. If proposition P is true, then the proposition not P is false. If proposition P is false, then the proposition not P is true. Find the negation of the proposition Usama's PC runs Linux and express this in simple English. Solution. The negation is, it is not the case that Usama's PC runs Linux. This negation can be more simply expressed as Usama's PC does not run Linux. The proposition conjunction. The conjunction of two propositions. Let P and Q be propositions. The conjunction of P and Q, denoted by P meet Q, is the proposition P and Q are. The conjunction P and Q is true when both P and Q are true and is false otherwise. Find the conjunction of the propositions P and Q where P is the proposition. Usama's PC has more than 16 gigabytes free hard disk space, and Q is the proposition. The processor in Usama's PC runs faster than 1 gigahertz. The conjunction P and Q is the proposition Usama's PC has more than 16 gigabytes free hard disk space, and its processor runs faster than 1 gigahertz. For this conjunction to be true, both conditions given must be true. It is false when one or both of these conditions are false. The truth table of such conjunction is given as the proposition P, the proposition Q, the proposition P and Q, disjunction. The disjunction of toe propositions. Let P and Q be propositions. The disjunction of P and Q, denoted by P or Q, is the proposition P or Q. The disjunction P or Q is false when both P and Q are false and is true otherwise. Find the disjunction of the propositions P and Q where P is the proposition. Usama's PC has more than 16 gigabytes free hard disk space, and Q is the proposition. The processor in Usama's PC runs faster than 1 gigahertz. The disjunction P or Q is the proposition. Usama's PC has at least 16 gigabytes free hard disk space, or the processor in Usama's PC runs faster than 1 gigahertz. The truth table of such disjunction is given as comparison between
In the following
table and
we will
disjunction.
compare
Between conjunction and disjunction. The conjunction P and Q is true when both P and Q are true and is false otherwise. The disjunction P or Q is false when both P and Q are false and is true otherwise. Exclusive OR. Let P and Q be propositions. The exclusive OR of P and Q, denoted by P exclusive OR Q or P XOR Q, such proposition that is true when exactly one of P and Q is true and is false otherwise. Let P be the propositions that state a student can have a salad with dinner. Let Q be the propositions that state a student can have soup with dinner. What is the exclusive OR of P and Q? The exclusive OR of P and Q is the statement that is true when exactly one of P and Q is true. That is, PQ is the statement a student can have soup or salad, but not both, with dinner. Note that this is often stated as a student can have soup or a salad with dinner. The truth table of XOR given as the conditional statement, if P, then Q. Let P and Q be propositions. The conditional statement P implicates Q is the proposition if P, then Q. The conditional statement if P, then Q is false when P is true and Q is false and true otherwise. To illustrate the conditional if P, then Q, P can be considered as hypothesis and Q can be considered as conclusion. For example, if you turn in a homework late, it will not be graded. If you get 100% in this course, you will get an A+. If you manage to get 100% on the final, then you would expect to receive an A+. If you do not get 100%, you may or may not receive an A+. Let P be the statement. Maria learns discrete structures, and Q the statement. Maria will find a good job. Express the statement if P, then Q as a statement in English. If P, then Q represents the statement, if Maria learns discrete structures, then she will find a good job. Maria will find a good job when she learns discrete structures. For Maria to get a good job, it is sufficient for her to learn discrete structures. Maria will find a good job unless she does not learn discrete structures. The truth table of the implication if then given as logical equivalence. The conditionals if P, then Q, and not P or Q are logically equivalent. Truth tables are the simplest way to prove such facts. A comparison between logically equivalent conditionals if P, then Q, and not P or Q given in the following truth table Contrapositive. Contrapositive of the proposition, if P, then Q, is the proposition, if not Q, then not P. Any conditional and its contrapositive are logically equivalent, have the same truth table. The contrapositive of the proposition, if you get 100% in this course, you will get an A+, is the proposition, if you do not get an A+ in this course, you did not get 100%. A comparison between the proposition if P, then Q, and its contrapositive is given in the following truth table. Biconditional statements. Let P and Q be propositions. The biconditional statement is the proposition P if and only if Q. The biconditional statement P if and only if Q is true when P and Q have the same truth values and is false otherwise. Biconditional statements are also called bi-implications. Let P be the statement, you can take the flight, and let Q be the statement, you buy a ticket. Then P, if and only if, Q is the statement, you can take the flight, if and only if you buy a ticket. The truth table of the bi-implication given as truth tables of compound propositions. Truth tables of compound propositions. Construct the truth table of the compound proposition. Truth table for the compound proposition. Logic and bit operations. One can use a 1-bit to represent true and a 0-bit to represent false. Find the bitwise OR, bitwise AND, and bitwise XOR of the bit strings. Solution. Future work. In the next lectures, we will discuss the following topics: applications of propositional logic, logic circuits, propositional equivalences, using De Morgan's laws, predicates and quantifiers. Thank you for listening.